transaction management. And finally, we will wind up the session by learning Spring Aop terminology and configuration. And also, don't miss the key takeaways from this tutorial at the end. I hope I made myself clear with the agenda. Now, without any further ado, let's get started.
Let's start with Spring MVC architecture and components. The problems in enterprise application development with Servlet and JSP. Servlet and code are not usable. Web designing tools can't be used in case of Servlet. Parallel development is not possible. To solve the problem, Sun Microsystems introduced two design patterns for developing enterprise applications. Model 1, page-centric model, and Model 2, MVC. So here we have a request coming in to the JSP page. The request is forwarded to the Java bean so that the object can be created. It connects to the enterprise server or data source, and then the response is generated to the browser. Request is sent by browser and received by JSP. Java bean object is created and business methods are called. If required, it communicates with the databases to get the required data. JSP then displays the processed data to the end user. There is no clear separation of responsibility. JSP acts as both controller and view, and the business logic is separated using Java bean. So now here you can see that the request comes to the servlet, which acts as the controller. The servlet can actually connect to the model Java bean, which maps to the data source using some ORM like Hibernate. That content can directly be pushed into the JSP as well in case there is no data, and it can then go to the model bean and retrieve data from the database via the JSP as well. And finally, the response is sent to the browser. Controller or servlet receives requests from browser and captures the input. Controller invokes the business method of model or Java bean. Model connects with database and gets business data. Model sends response to controller, keeps the processed data in heap memory request, session and servlet context, and controller switches the control to appropriate view of the application. The limitations of the MVC model: clear separation of responsibility, code reusability, single point entry for application, and support for multiple view technologies. Spring MVC is used to develop web application that uses MVC design pattern. Spring MVC is meant to make web applications development faster, cost effective, and flexible. Contents of Spring MVC: we have the dispatcher servlet, we have the handler mapping, the controller, mode and view, and view resolver. The dispatcher servlet, it is given by Aop Spring Framework.dispatcher servlet. It controls the front controller design pattern, and whatever URL comes from client, servlet intercepts the client request before passing the request object to controller. In the web config file, write servlet mapping in such a way that dispatcher servlet is invoked for client request. Then we have the handler mapping. It is an interface implemented by objects to define mapping between request and handler objects. When a request is made to Spring's dispatcher servlet, it hands over the request to handler mapping. Handler mapping inspects the request, identifies the appropriate handler execution chain, and it delivers it to dispatcher servlet. Handler mapping provided by Spring MVC module can be implemented in many ways. Bean name URL handler mapping, which is the default handler mapping class that maps the URL request to the name of the beans. If URL pattern welcome.htm is requested, dispatcher servlet will forward the request to welcome controller. If street name.htm is requested, it will forward the request to street name controller. And if process credit.htm is requested, it will forward the request to process controller. The controller are components that are called by dispatcher servlet for any kind of business logic. All controllers implement controller interface. The types of controllers are abstract, multi-action, and abstract wizard form. There are components called view resolver. Their job is to provide mapping between logical view name and actual physical location of the view resource. Then we have the model and view. It is represented by class org.springframework.web.servlet model and view, and is returned by the controller object back to the dispatcher servlet. This class is just a container class for holding the model and the view information. The model object represents some piece of information that can be used by the view to display the information. This gives abstraction in the Spring framework. Any kind of view technology can be plugged into the framework, like Excel, Jasper reports, PDF, XSLT, FreeMarker, HTML tiles are supported frameworks. Then we have the view resolver. It is an interface implemented by objects to resolve views using name Spring MVC's module. It encapsulates the module view and the view object in a single entity, which is represented by the object of class model and view. To resolve the view object, dispatcher servlet view resolver is used. Internal resource view resolver, it resolves the logical name of the view to an internal resource by prefixing the logical view name with the resource path and suffixing it with the extension. It resolves the logical name of the view to the bean name, which will render the output to the user. The bean should be defined in Spring App context file. This view resolver is the same as bean name view resolver. The only difference is that instead of looking for the beans in Spring's application context file, it looks for beans defined in a separate XML file. Spring Mvc Framework. The Spring Mvc Web Framework provides model view controller architecture that can be used to develop flexible and loosely coupled web apps. So here we see the steps. The request comes to the servlet dispatcher. It goes to the handler mapping. The handler mapping sends back to the respect dispatcher servlet that accesses the controller. We then call the handler request method on the controller, which calls the business methods on the service, which in turn calls the DAO method, which talks to the database and gets the response. The response is sent to the service, sent back to the controller, sent back to the servlet dispatcher, which forwards it to the view resolver, so the right view can be returned to the servlet dispatcher. The servlet dispatcher then picks up the model, attaches it to the view and generates the response. So client requests a resource in the web application. The Spring Front controller dispatcher servlet requests the handler mapping to identify the particular controller for given URL. Handler mapping identifies the controller and sends it to the dispatcher servlet. Dispatcher servlet calls handle request method and passes these two objects to the controller. Controller calls the business method. Service class calls the DAO method for business data. DAO interacts with the database to get the data. Database shares the result. DAO returns this result data to service. DAO data is processed according to business requirement and returns to controller. Controller returns model and view object back to font controller. Dispatcher resolves actual view by consulting the view resolver object. View resolver renders view to the dispatcher. Dispatcher servlet consults the view to the dispatcher servlet. View executes and returns HTML to the dispatcher servlet. Dispatcher servlet sends output to the browser. The request processing workflow of Spring Web Mvc dispatcher servlet is illustrated in the following diagram. The handler mapping going to the dispatcher servlet. Second is the controller data exchange with the dispatcher servlet. Then it communicates with the view resolver. And finally the view and the response is sent out. After receiving an HTTP request, dispatcher servlet consults the handler mapping to call the appropriate controller. The controller takes the request and calls the appropriate service method based on used get or post method. The service method will set model data based on defined business logic and return view name to the dispatcher servlet. The dispatcher servlet will take help from view resolver to pick up the defined view for the request. Once view is finalized, the dispatcher servlet passes the model data to the view that is finally rendered on the browser. Configurations required for Spring Mvc. Map requests that you want the dispatcher servlet to handle using URL mapping in Web XML. Create servlet name servlet XML file. Define a controller. Create a view. So you map requests that you want the dispatcher servlet to handle by using URL mapping in Web XML file. Use the following code. Declare the map hello web dispatcher servlet. The web.xml file will be kept in webinf directory. Then you create the servlet.xml file. Framework will try to load the application context from a file named servlet.xml located in the application's web content directory. The file name is helloweb.xml. The servlet name XML file will be used to create the defined beans, override the definitions of beans with the same name in the global scope. The component scan tag will be used to activate Spring Mvc annotation scanning capability, which allows you to make use of annotations like controller and request mapping, and the internal resource viewer resolver will have rules defined to resolve the view names. We define a controller. The @controller annotation indicates that a particular class serves the role of a controller. The @request mapping annotation is used to map a URL to either an entire class or a particular handler method. The request mapping method is used to declare the print hello method as the controller's default service method to handle HTTP GET requests. Then we create a view. Spring Mvc supports many types of views for different presentation technologies. These include JSP, HTML, PDF, Excel worksheet, XML, Velocity template, XSLT, JSON view in WebInf.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit Skill Up by Simplilearn. Click on the link in the description to know more.
Finally, the Spring MVC program. Let's write a simple web-based application using Spring MVC to create a Spring MVC model to display Hello World. So the request will come in here saying hello.jsp. We will use @request map ping. Then the dispatcher servlet will communicate with the hello controller. Then the internal resolver view resolver. And finally the hello.jsp, which will generate the response. The Hello World example uses Spring Web Mvc Framework to follow the model view controller architecture. The controller is responsible for processing user requests and building an appropriate model. It then passes the model to the view for rendering. In this example, Hello Controller Java class is controller. The view is responsible for rendering the model data. In general, it generates HTML output that the client's browser can interpret. In this example, hello.jsp is the view. We create a dynamic web project with the name Hello Web. We then add jar file to web content web-inf lib. Then we create a Java class Hello Controller under src folder. Then we create Spring configuration file web.xml and Hello Servlet under the web content inf folder. Then we create a subfolder with a name JSP under web content. Then we create a view file hello.jsp under the subfolder. The final step is to create the content of all the source and config files and export the application. Here are the steps. We create a dynamic web project that we have already learned. We add the following jars: Servlet API, Common Logging, Spring Aop, Spring Beans, Spring Context, Spring Core, Spring Expression, Spring Web MVC and Spring Web. Then we write the @controller and request mapping to /hello. We write the controller with the request method as get, and we say model.addAttribute message hello Spring Framework. Then we create the Spring config file that maps the dispatcher servlet object and the Hello Web. Then we map the Spring Framework internal resource view resolver as well, and we put the web-inf/jsp property mapped to that particular folder path. Then we create the subfolder with a view hello.jsp, which simply returns hello world and $of the expression. To run the application, we say localhost port hello web and hello. We'll write a simple web-based application that makes use of HTML form using Spring MVC framework to submit the data to the controller and display a processed result. So the moment we say project name /employee, it will go to the dispatcher servlet, which will talk to the employee controller, retrieve the employee object, move to the internal resource view resolver, which picks up the result.jsp and employee.jsp views and send it out as a HTTP response. MVC architecture for form handling example. The form handling example uses Spring MVC framework. It follows model view controller architecture. The model encapsulates the application data and consists of POJO. It creates employee class containing ID, name and age. The controller is responsible for processing user request, building an appropriate model and passes it to the view for rendering. It creates an employee controller.java class to call employee class methods. The view is responsible for rendering the model data, and in general it generates HTML output that the client browser can interpret. Java JSP files, result.jsp and employee.jsp are used to display employees information. Steps to write a web-based application using Spring MVC. We create a dynamic web project and add the required jar files. We then map the request that you want the dispatcher servlet to handle by using URL mapping and web.xml. You then create the Java class employee. You then create employee controller in src folder. You then create Spring config web.xml and servlet.xml under web context web.inf. You then create a subfolder with the name JSP under web context inf. You then create view file employee.jsp. You then create second view file result.jsp, and the final step is to create the content of all the source and config files and export the application. Now we create a dynamic web project and add the required jar files: common logging, Aop Spring Framework ASM, Aop Spring Framework Bean, Aop Spring Framework Context, Aop Spring Framework Core, Expression, Web Servlet Web, and Spring Web.jar. We then define the Spring Web configuration file web.xml, where we set up the dispatcher servlet. We give the servlet name as Hello Web. We then set up the employee class with age, name and ID. We then create the controller with a request mapping of a URL/employee and map to a request.get method. We then return model and view with the employee and command and the new employee object. We then do another mapping for the request method.post. This is from the form data to be posted. We provide the add employee method and add attribute mappings for name, age and ID. Next, we create a Spring config file web.xml and servlet.xml, which map the JSP page. Then we create a subfolder in a view which maps the view information as a employee.jsp file, where we create a simple table to print out the data. We create a second view called result.jsp, which has a separate table that this gives us the name, age and ID of the employee. We create content for all the source and config files, and we run the application. Let's look at a demo on Spring Web Mvc. Let's start with a small demo demonstrating the capability of Spring Web Mvc. So let's move to Eclipse. So Spring Mvc is an end-to-end solution for complete web app development. The servlet plays the role of the controller and JSP plays the role of the view. It follows the fun controller design pattern. This means there will be a servlet as a controller and the model caters to collecting the data. There is complete sync between the model. The view is handled by the controller, which is a form of MVC design pattern. So Spring Mvc has a front controller, which is the dispatcher servlet. So we have created a dynamic web project and we have added the libraries. So the reference libraries are all the Spring libraries. In addition to that, we have added the commons logging, which is the other important library that we have added. We have a views folder that has 4 views: home, profile, register trainee and success. Let's look at the web.xml file. Here we have the dispatcher servlet configured with the name as my servlet, and here we are configuring my servlet with a URL pattern of / indicating that any request that comes to the dispatcher servlet, which acts as a controller, will be catered to by the dispatcher servlet. So the moment you put a /, which is the root URL, in the address bar, the request will come and hit the dispatcher servlet. Then we have the myservlet-servlet.xml file. So here we can actually see that the Spring Web container is going to look for this file. It is going to look for JSP pages inside this path, which is webinf/views, and that is where we have stored our JSP pages. It will search for the controllers in the com.controllers package. And here in the source, in the com.controllers package, we have set up our controllers, as you can see here. The internal resource view resolver will find out which particular JSP page is to be returned. So the prefix is the path where the JSP are stored, and the suffix is it's going to postfix all the view names with a .jsp extension. Next we come to the mycontroller.java file. We use the annotation controller. We are mapping to the root. So if somebody gives the URL, the end user passes the URL as a /. We are going to print home in the console and simply return the home.jsp page. So the suffix will be appended to this. We have another function called sayName. So in case we request for this particular URL route, we will get the first name parameter from a form. We will map the attribute of this particular value, first name, and we will return the profile view, which is again present in the views folder as we see here. We have a third route set up for the URL login. So if the URL is /login, we will trap the username and password fields from the form. We will check if the username and password equals Tom and Jerry. We will add the attribute and we will return the profile page. If there is an error, we will simply return an error message. So that constitutes the my controller. let's look at the home.jsp. We have the say name action method, which will post to the say name request map that we saw in the controller. The method is post. We have a submit button with fname, and we have a login controller with username and password and a submit button, and this is mapping to the action method login. And those are the two action methods we saw. We are mapping to say name or login. We'll come to the home page and we'll execute this. We'll go to the default route, which is just a slash, which takes us to the home page. And here it simply gives us a welcome message as of now, which says hello, welcome to Spring, which we see is the default welcome message that we are actually getting. And we also have a say name function that is actually getting mapped when we click on this button. And we are going to route to a success page. So here, let's print first name, and we can see here that we are actually going to map to the first name function. And if we go to the controller, we have created an attribute first name to which we are mapping this value. Okay, and we are simply returning the user information. So in case there is a success, it will simply go ahead and route to that particular URL. So we'll just provide, or rather, let me go here rather than the success, and we'll make that change. So we'll go to the profile because we are navigating there, and here we have a first name. And now if you see here, we are saying that we are going to post this form to say name. First name is going to be the attribute that we are going to trap, and we are going to return profile. So the first name attribute that we are going to trap here, if we look at the home.jsp, okay, the user is going to enter a first name which we will trap as an attribute. So here that value is going to get trapped. We then return the profile JSP. When I go to the profile JSP, we are simply outputting that attribute first name. So this is my page execution. I have just entered a first name. I'm going to click on the submit button, and it says welcome that particular user, right? If I add another user, it actually goes and traps that user ID. So again, the flow is that in the controller, it's hitting this particular request map. It then traps the fname, stores that value into an attribute called first name, and forwards it to the profile page. The profile.jsp is returned by the controller and simply prints the first name. Now we have another page here, which is register trainee. We are posting to an add trainee method. Okay, we are posting to an add trainee method. The command name is trainee command. And we have here, if you look at this, we have actually included a custom, or rather a system defined tag library, which is springframework.org tag/form. So what we are using here is Spring forms rather than the system defined HTML5 forms. And here we are saying sform : which is the prefix for this particular namespace that we have imported on the top. The action is add trainee, and we have a trainee name, we have a marks code, we have a contact number, and a submit button. Okay, and now we are already going and setting part to COM controllers. So in the COM controller, we've created a register controller. Here you see that we have a request map for register and a request map for add trainee, and here you see the trainee command that is actually getting trapped. So the trainee information will automatically be passed here, and this is the model map which acts as a scope which allows us to pass data between the controller and the view. So this trainee object acts like the model data. So if we come to the com.to package, you actually see the trainee class which has trainee name, marks code, and contact number. It has a parameterized constructor, it has an overridden toString, default constructor, and getter and setter. That's all the trainee class actually has. The register controller, as we saw, has two maps, a register function that returns register trainee.jsp, maps to the attribute trainee command, and a add trainee map that accepts the trainee object along with the scope, the model map, which passes data between the controller and the view. We are adding attribute trainee and we return success. Okay, so if I go to the success.jsp, we are printing the trainee object. If you look at the register trainee, here you see the command name that we are trapping and trainee name, marks code, contact number, which map to the fields that we have in the model class or the entity class, which is the trainee itself. So now if we actually look at so let's close this, come back. We don't add any credentials. We click on login and it says invalid login credentials. Okay, so this is the login that is getting called. So you see here it maps to the login, and here if we do not enter anything, it simply returns invalid login credentials. So this is the login that's actually getting hit when we click on that button. And if you look at the register trainee, we actually see the input type over here equal to submit, and the moment we hit that particular login URL, it will simply throw this message saying that you did not enter the right credentials. So that is the login screen for us. Okay, now if I actually add the right credentials, so if I add the correct credentials here, or let's say we enter the incorrect credentials, let's say Amit and password, and we say login, it continues to say invalid login credentials, right? So in the home.jsp, you actually see the login. So this is the login block, which is giving us that action equal to login, username, password, and it is displaying $error message, right? So the moment I click on this input button, it looks for a JSP, or rather it looks for a controller which has a request map. So this JSP page looks for a controller that has a request map of login. So inside the my controller, I have a request map of login. It will go here. It traps the username, password, checks. If it's not Tom and Jerry, it goes to error message. If it is Tom and Jerry, it displays profile, right? And if I look at error message is being printed in the same page below. So in the home.jsp, we actually are, if you look at the home.jsp page, $error message is being printed, and that's why you get the invalid credentials out here. Okay, and if it is a success, it will show you the success page and print that information. Okay, it will just display. So if you look at the my controller, what we are doing is we are displaying the profile page here. So if I go to the profile page, it will just display the first name. Okay, so let's try that. So here, if I say Tom and Jerry, it should just display the first name successfully saying Tom. So when I log in, it says welcome Tom. Okay, the URL continues to be login. Now, when I click on this register link, what happens? So let's look at the home JSP again. href equal to register. So when I click on the register link, I simply have a registration which says click here to register. Okay, and I already have a register trainee form created, and this is created using Spring Forms, as we discussed, by importing the tag library for Spring Forms, right? So that's the register trainee. Now I have a separate controller that is managing that. So here is the register. So moment I click on that link, it will hit this request map and it will bring up the register trainee.jsp. Okay, and remember we had added the suffixes here in this particular file. So when I say register trainee, the .jsp suffix will already be automatically be added. So we'll try that. We'll click on register, and here you see the register trainee Spring form has come up. So we enter the trainee name, we enter the marks code, and we enter the contact number, right? Now if you look at the register trainee form, this is posting to add trainee. So if I go to the register controller, here is where I have my add trainee. it accepts the trainee object as a parameter, maps to trainee command, and the scope, which allows us to pass information between the controller and the model. And here we are mapping the trainee object and just returning success.jsp, and in success.jsp we are simply printing the trainee object. So let's see when I click on submit query. So let's try the register now. So when we click on register, we'll enter a name for the trainee. We'll enter the marks code and we'll enter some contact number, and we'll click on submit query, and there you see the trainee object actually getting displayed. So in the success page, we were actually displaying the trainee object. On the register trainee, as we discussed, we were connecting to the add trainee action. In the register controller, we had the add trainee action. We were passing the trainee object along with the model map and adding the trainee attribute to the map, and finally returning success. And on the success page, we just went ahead and printed the trainee object. So you saw how the Spring MVC pattern got the request to the dispatcher servlet, it forwarded it to the right model, picked up the model data, and went and displayed successfully the required view, which was the final view that actually got registered for us, and that is the success.jsp page that finally got displayed. Let's start with JDBC and Spring Hibernate, or JDBC Data Access Object. This is used to build data access layer of enterprise application. It is a mechanism to connect to the database and execute SQL queries. The database related logic has to be placed in separate classes called DAO classes. Let's do a quick comparison. The difference between JDBC and Spring JDBC based on first, transaction management. JDBC doesn't support to enable and disable transactions declaratively, whereas Spring JDBC supports. Distributed transaction management, Spring JDBC has support for it. Annotation based transaction management, Spring JDBC has support. Resource allocating logic. In JDBC, the connection statement and prepared statement have to be allocated explicitly by the developer. Spring provides template object and it expects the database resource allocation logic. Resource releasing logic. In JDBC, developer explicitly writes the logic to release the database resources. Spring provides the JDBC template object. Exception handling. JDBC throws Java SQL exception. There won't be specific exceptions for specific problems. And for Spring JDBC, it provides fine-grained exception handling mechanism to deal with database. So here we see the DAO classes connecting to the Spring JDBC framework, which is an additional layer, which then connects to the JDBC API and finally talks to the database. What is the advantage of using Spring JDBC API? It provides the capability to establish the connection and interact with database. It simplifies the development of JDBC Hibernate, JP and JDO. It provides multiple templates to interact with database. JDBC template, Hibernate template, JDO template and JPA template. The terminologies of Spring JDBC API. When a connection is opened and closed when required in an application, the object utilization becomes difficult and the cost of implementation increases. In such cases, connection pooling is used. It is a mechanism of pre-creating a group of database connections and keeping them in cache memory for use and reuse. It provides high performance and efficient resource management. It is an interface that is an object-oriented representation of connection pooling. That's what the Java SQL data source does. It is a connection factory for Java application. It is an alternative for driver manager and provides database connections to the Java application. Its implementation classes are provided by the following connection pooling mechanisms: Apache Basic Data Source, Spring Driver Manager Data Source, and C3PO Combo Pool Data Source. The JDBC template is used to handle common logic. It is an abstraction of the JDBC technology. The methods provided by JDBC template are for insert, update and delete methods. The template provides update method. For find by balance, find by all, row count available in JDBC, Spring Templates provides query, query for int, query object, query for map, query for list. To handle batch updates, Jdbc template has convenient methods. Here we see some Jdbc template methods. The update for insert, update, delete, for DDL, for executing query by using prepared statement, for fetching records and fetching records using row mapper. Let's talk about Spring Jdbc implementation in an application. To implement, we create a database and table in the database. We then create Java projects in Eclipse. We then create the Spring Bean class or the Pojo. We then create a DAO. We then configure data source and Spring configuration XML file. We then create Spring Bean or Spring container either by XML Bean factory or application context. For implementing Spring Jdbc in an application, we create database and table in database. The syntax to create database is create database name, and the syntax to create the table is create table name with the respective columns. Next step, we create a project in Eclipse. Then we consider a user class that has 3 member variables, ID, name and salary. We then create a DAO class where we create an object of Jdbc template. We set it in the constructor. Then to save the user, to update the user and to delete the user, we actually write string queries and pass them to the Jdbc template.update method. To configure data source and Spring Bean configuration XML file, the Jdbc driver can be used to establish connectivity to the database during development of basic unit or integration testing. Spring has 2 data source classes, driver manager data source, which returns a new connection every time a connection is required, and single connection data source, which returns the same connection every time a connection is required. We then configure data source and Spring Bean via the XML file. So here you see the Bean ID configured to driver manager data source, the property driver class name configured to the driver, the URL configured to the URL of the database, the username and password. The ID Jdbc template configures to the Jdbc template class, and the data source gets a reference name. Then we create a Bean ID for injecting the user DAO class, and finally we reference the Jdbc template. The last step, create Spring container either by XML Bean factory or application context. So here we use the application context. We pass the XML file reference. We get the user DAO class injected. We then save the user information and print the status. Let's look at a demo where we will implement the Jdbc template using a combination of Jdbc and Spring Hibernate. So we'll move to Eclipse. The first thing we'll do is we have to add the reference libraries. So we now know that Jdbc template is a design pattern by Spring. It welcomes the Jdbc ORM Hibernate also to come in and assists us from saving our time with writing a lot of config code. So the template design pattern is actually one of the creational GOF design pattern. The architecture and configuration is pre-written, so we can focus on the business and persistence logic. So previously, Jdbc had lots of configs where we had to create the connection, etc. Spring now takes care of all of this, and also connection pooling and exception management as well. So Jdbc template helps with this, and Spring takes care of the end-to-end Jdbc config. So I have created a new project. Within that project, we have added comments.login reference library, and also all of the Spring jars along with the Jdbc jar to connector to SQL or MySQL database. You can add Oracle one as well, AspectJ and AspectJ Weaver, which we covered in the last session. So now let's open up the employee class. It has employee ID, name, age and password, and simple setters and getters, and also a toString override. That's there in the employee class, and this is the object that we want to save into the database. We've also created a database in SQL with employee ID, name, age and password, and that is ready. Now we have the mapper class, which is actually creating an object of employee, and it is mapping the ID, age, name and password of the employee to the database fields ID, age, name and password, and it's returning the employee reference. Then we have the DAO class, where we are defining the data source, the template object and the transaction manager object, because we also want to learn transactions here and run this as a transaction. In the set data source, we are initializing the Jdbc template. We have an add employee method which takes the employee object and inserts it using a parameterized query into the employee table. So we fire the update method, we give the query and the 4 parameters of ID, name, age and password, and we return the count of the records that have been updated. We have another method that gets all the employees. It returns a list of employees. We say select star from employee, and we simply pass the query, the SQL statement and the mapper class, so that it maps the values that are there in our employee object to the database fields, and we return the list employee. Here we are just giving a suppress warning message so that it allows a cast from the return of the query method to a list of type employee. Then we are getting all employees based on the age. So we pass the age, we write a parameterized query, select star from employee where age is equal to question mark. Again, we suppress the error that is returned and we return the list of employee. Then we have a multi-action method which takes the employee object. It simply prints performing multiple actions. It defines a transaction scope and a transaction status as well. We then write the query. The first thing we do is we insert into the employee a set of values which again are passed using the update method of Jdbc template, and we print the result saying how many records have been inserted. Then we fire another query in the same transaction scope to get us the employee which has maximum age. We then fire that statement and we print the object of type employee which is returned, which has the maximum age, and we commit the transaction. So if there is any error with either of these statements, the entire transaction will roll back, and that is what we are doing if there is an exception. These are the setters and getters for the platform transaction manager and the template object. We then come to the beans.xml. This is the standard header. Here we see we are configuring the Jdbc driver and also configuring the driver manager data source. We give it an ID of data source. We connect to our database, which is called Simpli2. We provide the username password, which is root. We then define the transaction manager bean to be injected, which is of type data source transaction manager, and we give it a reference of our data source which is connected to the MySQL database. We then inject the object of the employee DAO class. We also give it the reference of the data source, and we give it the reference of the transaction manager object that is injected. So with this project structure, we are now ready to attempt to use Jdbc template and connect to the database, create a new record and attempt to see if it actually works for us. And you see the value here of actually using Jdbc template, because Jdbc template takes over the management of the connection, etc., rather than we going ahead and writing the code. So we'll go to the main class. Here we have created an object of application context, so we can load the beans.xml, and we are also getting the object injected using dependency injection of Spring, which is the DAO class object. We then creating a new employee object with an employee ID, name, age, password. We are calling the add employee method and passing the employee object and simply printing this is the list of records that have been added. And here you see one record has been added when we executed that, which is the output that we have got. Let us check in the database. And you can see the record actually got added into the database. We will now try to insert one more record and validate. So let's make it 104 and we'll change this to S, change this to TD, change the age as well to 20. Let's execute this once more and we will check, and the second record has actually now got added, right? We did not save this and hence you saw the same ID. So let me run it once more after saving and execute, and you see the 104 record that we added has now got updated in the database. Now let us retrieve all the employees using the second statement that we have, or the function that we have. So here I will uncomment this. So here we are saying get all employees for employee in the list and simply print out the employee information. And there you see the employee records, 3 records that we inserted are successfully getting printed. Let's comment this. And we'll now call the method that we have that is performing multiple actions. It is also inserting a value in the database and also getting us the maximum age. Okay, so before that, let me just insert a record which has the maximum age. So we'll uncomment this and we will say 105 Y, and we'll change the value here, make it 50, save this, execute. Oops, I think I have not commented successfully. Oh yes, this is it. Save this, execute. 1 record added. So that's the record now with the maximum age of 50. We'll come down now and we'll execute the multiple statement method that we had written, and it's running in a transaction. So it says performing multiple actions, 1 record inserted, and it printed the employee details 50, which has the maximum age. Right, and it would have also updated the database and executed that value. So here you see the actual value of using the Jdbc template and how it has actually helped us to retrieve relevant data from the database by outsourcing most of the job to the Jdbc template framework.
If getting your learning started is half the battle, what if you could do that for free? Visit Cglib by Simplilearn. Click on the link in the description to know more.
Let's move to integrating Spring with Hibernate. Spring Framework provides integration with Hibernate, toppling Ibatis and JPA, and the reasons to integrate Spring with Hibernate. In large applications, this integration makes the maintenance very easy. When integrated, caching and other performance tuning is handled automatically. Database can be changed easily without affecting the application code, and integrating Hibernate application with Springs avoids creating the hibernate.cfg.xml file. All information can be contained in application context XML file. Configuring application XML. We configure session factory using class annotation session factory bean. We define Hibernate template by passing session factory, and for the database transaction, we define Hibernate transaction manager using the transaction manager configure Aop. Hibernate template is a helper class that simplifies Hibernate's data access code. It automatically converts Hibernate exceptions into data access exceptions by following org.springframework.DAO exception hierarchy. The structure of Hibernate template class: public class Hibernate template extends Hibernate accessor, implements Hibernate operations. So we have multiple methods available like persist to save the object, save to persist given object and return the ID, save or update to persist or update given object ID, to update which updates the object ID, to delete the ID, to get the object, to load the object on the basis of given ID, and to return all persistent objects. Let's look at how to create applications using Spring Hibernate template. We create a database, we create Java project in Eclipse, we create user Java file, it is the persistence class, we create user DAO Java file, it is the DAO class that uses Hibernate template, we create application context, it contains information of data source session factory, and then we create test Java file, it calls methods of user DAO class. Here, this is how we create the database. We have already discussed how to create a project. We then create the user.java file and mark it with the entity and ID tag as an annotation. We then create the user DAO file where we create the Hibernate template instead of the Jdbc template, and this is how we would persist the information using the persist method. Finally, we create the application context XML file. Then we create the session factory so that we can register the bean. So we are registering the template by providing the template reference to the employee DAO bean. And then lastly, we create the main where we load the XML file. We pass the bean ID to get the bean object and we persist the information. So let's start with a demo demonstrating the Spring Hibernate template. So we have already seen the Spring Jdbc template. We will now see the Spring Hibernate template, and the benefit of using this would be that the Spring container will initialize the Hibernate container for us, and Spring will take care of all the things like creating, opening the connection and configuring the connection and setting up the data storage for us, etc. So let's get into Eclipse so that we can set up our demo. We'll start with understanding what are the jars to be referenced. First of all, we'll reference all of the Spring Framework jars. In addition, we'll reference common logging, the Hibernate jars, and the MySQL connector, which is the Jdbc driver to connect to the MySQL database. Now we'll start with the trainee class, which is going to play the role of the entity class or the DAO class to be saved. So we are going to mark it as entity @table annotation. So this remains the same from the previous demo. @ID, since this is a primary key and we want to auto generate the primary key as an identity column. So hence we have set generation type as auto. We have the trainee ID, trainee name, marks code, and contact number. We have the default constructor, the getters and the setters. The toString has been overridden, and we have the parameterized constructor. It does not take the ID since the ID is automatically getting generated. We then have the DAO class, where we are now defining the Hibernate template object instead of Spring template as we did in the previous demo. We have a getter and a setter that sets and returns that object. We have a add_trainee method that takes the trainee object. It creates the session by saying Hibernate template dot open session. It begins a transaction. It saves the trainee object that is passed to it and returns the ID. We then commit the transaction and return the ID out of the function. We also have a function called getAllTrainees that returns a list of type trainee. Here we are defining a new array list specialized to type trainee. We are then saying Hibernate template.load all the values mapped to this entity will be loaded here from the database, and we will return that list back. Now let's set up the XML. So here we've just added one more namespace, springframework.org/schema/p for persistence. And of course, the rest of it remains the same. Next we see that we've added the driver manager, jdbc.datasource.driver manager data source, com.sql.jdbc driver, that's the driver class name. The URL is localhost and name of the database is test. Username is root, password is root. Next we create the session factory that initializes the Hibernate session bean. We provide the data source, name data source, the reference is this particular data source, that is the database connection. The property name is annotated class com.2.trainee. So that's the trainee class in the com.2 package, that is the annotated class to be initialized. Then we set the Hibernate properties. This is the SQL dialect to communicate with the database. Okay, initially we will set this as create since we want to create the table. Show SQL true, so it generates the SQL in the console. Then we are creating a bean with ID temp, setting it to Hibernate template and referencing the session factory that we have created here. Post that, we create an ID DAO, we connect it to and map it to the trainee DAO class since we need to create an instance of that as well, and we reference the Hibernate template out here. So that's all that is there inside the beans.xml file. Now we just need to go and set up the main program. So we'll go to the main.java. This line remains the case same. The application context is loading the beans.xml. Post that, we get the bean name called DAO. That's the same name that we have actually specified here. That maps to the trainee DAO class. We create a new trainee, provide some values. We call the add trainee function and provide the method there to the DAO class. We then print all the trainees that are there in the database. So now you can see when we execute it, we create the table, we insert one value. So here you see the trainee value Vinay12 with the contact number actually gets returned with the select all. Now let's check in the database as well. Select star from trainee. Let's select the test database. Okay, and there you see this is the record with the ID automatically generated that we had actually inserted from the backend. So now here, if I need to add another record, let me make this 13. Let me change the value. We'll go to the beans class and change this from create to update and save this. Right, so there are two records now, trainee1 and trainee ID 2 that are returned, and let's refresh this and you see the second record also has got added with the name Ajay. So this shows us how it is pretty easy to set up the Jdbc template using the Hibernate template option and outsourcing all of the hard work to Spring. So Spring will take care of managing all of the connection. We actually did not create a separate CFG configuration file for Hibernate. It was the single beans.xml that actually did the job for us. Let's move to Spring Jdbc transaction management section of the Jdbc template integration. So here we'll start with Spring Jdbc transaction management. Now Spring provides extensive support for transaction management. This helps developers to focus on business logic rather than worrying about integrity of data in case of systems failure. Spring provides an abstract layer on top of different transaction management APIs. It helps application developers to focus on the business problem without having to know much about the underlying transaction management APIs. The concept of transactions can be described using the following 4 key properties known as ACID, atomicity, that requires each transaction to be all or nothing. If one part of the transaction fails, then the entire transaction fails if the database is left in a unchanged state. Consistency properly ensures that every transaction will bring the database from one valid state to another. Isolation ensures the concurrent execution of transactions result in a system state that would be obtained if transactions were executed serially, that is, one after the other. Durability property ensures that once a transaction has been committed, it will remain so even in the event of power loss, crashes, or errors. Platform Transaction Manager is a general interface of all Spring transaction managers. Spring has several built-in implementations of the interface that can be used with different transaction management APIs like Data Source Transaction Manager, Hibernate Transaction Manager, and JPA Transactional Manager. Methods of Platform Transaction Manager. We first have the transaction status. This method returns a currently active transaction or creates a one according to specified propagation behavior. We have commit that commits the transaction and rollback that rollbacks the transaction, which we saw as part of the demo. Here we have the transaction definition, which is the core interface of the transaction support in Spring, and it is defined as follows. We have get propagation behavior method, which Spring offers all of the transaction properties and propagation offered by EJB-CMT. Get isolation level that returns the degree to which the transaction is isolated from work of other transactions. Get name, which returns the name of the transaction. Get timeout that returns the time in seconds which the transaction must complete. And is read only. This method queries whether the transaction is read-only. Transaction Status Interface provides a simple way for transactional code to control transaction execution and query transaction status. We have the HaveSamePoint method that returns whether this transaction internally carries a save point, is completed, the method returns whether the transaction is completed, whether it is already committed or rollback. Is new transaction, the method returns true in case the present transaction is new. Rollback only, the method returns whether the transaction has been marked as rollback only. Set rollback only, the method sets the transaction as rollback only. Spring supports two types of transaction management, programmatic and declarative. In programmatic, it manages transaction with help of programming. It uses Programming Transaction Manager directly to implement the programmatic approach, to implement transactions and to create instance of transaction definition with appropriate transaction attributes. Once the transaction definition is created by calling getTransaction method, which returns an instance of transaction status. The transaction status object helps in tracking the current status of the transaction, and programmatic transaction management uses the commit method of Platform Transaction Manager to commit the transaction. Then we have the declarative transaction management, which separates transaction management from the business code. It allows you to manage the transaction with the help of configuration instead of hard coding it in your source. It uses annotations or XML based configurations to manage the transactions, and it uses TX-advice tag, and this creates a transaction handling advice and defines a point cut that matches all methods needed for the transaction at the same time. Let's introduce ourselves to Spring Aop, or Aspect-Oriented Programming. Aop is used in applications that have cross-cutting concerns, that is, pieces of logic or code that are written in multiple classes, layers as per the requirement. Some common examples are transaction management, logging, exception handling, security aspects, and instrumentation. Let's understand the concept of concern. A concern is a piece of code that performs a specific task, and there are two types. Co-concerns are codes used for business logic. Cross-concerns are functions that are conceptually separate from the application's business logic but affect the entire service layer. Example: logging, auditing, declarative transactions, security, and caching. Aspect-oriented programming provides one way to dynamically decouple core concerns from cross-cutting concern. Aop is one of the basic components of Spring Framework, and the main idea of Aop is to isolate the cross-cutting concerns from the application code, thereby modelizing them as a different entity. Services layer deals with two types of concerns, core concerns and cross-cutting concerns. Spring Aop provides declarative enterprise services such as declarative transaction management. It allows users to implement custom aspects. Spring Aop is used to track user activity in large business applications. It uses Proxy as a mechanism to implement cross-cutting concerns in a non-intrusive way. Let's look at some Aop terminologies. What is an aspect? It is a feature or functionality that cross-cuts over objects. It has a set of API application programming interface that provides cross-cutting requirements. Join point, it defines the various execution points where an aspect can be applied. Point cut tells us about the join points where aspects will be applied. Advice provides concrete code implementation for the aspect. And target is a business object. It comprises of aspect business's core concern. Weaving represents a mechanism of associating cross-cutting concern to core concern dynamically. Proxy is an object produced through weaving. There are two types, static and dynamic. In static proxy, static method is used to develop and maintain proxy classes for each business method. In dynamic proxy, proxy is developed at runtime. Weaver is code that produces proxies. The proxy design pattern is an actual business object where it is wrapped into another unknown object known as proxy and substitutes that object in place of the actual object. We will discuss join point, point cut, and proxy in this lesson. Point cut defines where exactly the advice has to be applied in various join points. Generally, it acts as a filter for the application of various advices into the real implementation. Spring defines two types of point cut: static, where it verifies whether the join point has to be advised or not. It does this once the result is cached and reused. And dynamic, where it verifies every time as it has to decide the join point based on the argument passed to method call. So you see the point cut and the dynamic method matcher point cut, and finally the control flow point cut. So this is the structure and types that exist in terms of static and dynamic point cut. Let's talk about the static method matcher point cut, which has two types of point cuts. Name match method point cut. It interrupts a method via point cut in advisor. And abstract regex method point cut. Besides matching method by name, it can match the method's name by using regular expression. This point cut is used to verify join point based on pattern of the method name instead of name. Then we have JDK regex method point cut. It is represented by org.springframework.aop.jdk regex express method point cut, and Perl regex method point cut. It is represented by org.springframework.aop.support.perl5 regex method point cut. The dynamic method point cut. This point cut is used to verify the context from which business method call is made. If method call is made in specific flow, it will be advised, otherwise it won't. Point cut is an interface. It is represented by org.springframework.aop.pointcut. And the get class filter method returns a class filter object which determines whether the class object argument passed to the matches method should be considered for giving advices. A join point is a candidate point in the program execution of the application where an aspect can be plugged in. This point could be a method being called, an exception being thrown, or even a field being modified. These are the points where your aspect code can be inserted into the normal flow of your application to add new behavior. A point cut defines the join points where associated advice should be applied. So in terms of the join point methods, we have accessible object with a method, get static part which returns accessible object, and this returns the static part of join point. Get this returns the object that holds the current join point static part, and we have proceed to the next interceptor in the chain. How does AOP work? The proxy interrupts the call made by caller to original object. It will have chances to decide whether and when to pass on the call to the original object. In the meantime, any additional code can be executed. Spring uses the dynamic proxy approach where the caller calls to the business on the original object. A dynamic proxy class is a class that implements a list of interfaces specified at runtime so that a method invocation through one of the interfaces on an instance of the class will be encoded and dispatched to another object through a uniform interface. In the proxy pattern, a class represents the functionality of another class. This type of design pattern is a structural pattern. It creates an object that has original object to interface, its functionality to outer world. Proxy design pattern is used when we want to provide controlled access to a functionality. It is also used to save on the amount of memory used. Similarly, if you want to control access to an object, the pattern becomes useful. Let's look at the ways to generate dynamic proxy. The JDK approach, when the business class implements interface, JDK creates proxy for the business object. The Cglib approach, the Cglib.jar is used when a business class fails to implement any interface and JDK is unable to create the proxy. Advice refers to the actual implementation code for an aspect. Spring supports method aspect, different type of aspects available in Spring. Before advice, it executes before a join point but does not have the ability to prevent execution flow preceding to the join point. After advice, it is executed after business method call. Around advice, it surrounds a join point such as a method invocation. It can perform custom behavior before and after method invocation, and throw as advice is executed if actual method throws exception. To configure these advices, we have to depend on proxy factory bean. This bean is used to create proxy objects for the implementation class along with the advice implementation. The proxy property called proxy interface contains the interface name for which the proxy class has to be generated. The interceptor names property takes a list of advices to be applied to the dynamically generated proxy class. And finally, the implementation class is given in the target property. The before advice, now this is used to intercept before the method execution starts. For example, a system may need to perform some logging operation before allowing users to access resources. So whenever the caller calls the business method, all before advice code is executed prior to the business method. If an exception occurs in the method, after returning method will never be called. Configuring before advice. Develop a business interface in its implemented class. Develop a class that implements after returning advice interface. Override its after returning method. Cross-cutting code is written here. The after returning method is the target method to be invoked. The object arguments are various arguments that are passed on to the method, and object target is the target reference to the object that is calling the method. Finally, we get a proxy and make a method call. Here is the sequence diagram with the steps. So we have the client which calls the business method on the proxy, which is the interceptor. The proxy will call the before advise method. Control will return back to the proxy. The proxy will then go ahead and call the actual business method. So if you want to perform some action before your business method is called, you can write that code in the before advise function. After advise is used to intercept after the method execution. For example, a system needs to perform some delete operations after logging out. After advise is executed after the business method. So the steps for configuring after advise are as follows. We develop a business interface and its implemented class. We develop a class that implements after returning advise interface. We override its after returning method. We cross-cutting code is written here. The method is the target method to be invoked. The object arguments are various arguments that are passed to the method, and the object target parameter is a reference to the object that is calling the method. Then we get a proxy and make the method call. If an exception occurs in the method, after returning method will never be called. Here you see the sequence diagram. We have the client trying to call the business method, but the proxy intercepts. The proxy goes ahead and calls the business method, and after that it calls the after returning, and then the return will come back to the proxy. Around advise, it can change the return argument of the method call. It provides finer control regarding whether the target method has to be called or not, and it can be performed before business logic or after business logic. How do you configure around advise? It develops a class, or you rather set up a class that implements method interceptor interface. You then override its invoke method. You write the cross-cutting code. You get a proxy. You make a method call, and the parameter of the invoke method is to be passed. So here you see you have a client trying to call the business method. The proxy intercepts. The proxy attempts to call the business method and then immediately calls invoke, and then it calls the business method post that. When an exception happens during the execution of a method, throws advice can be used through the means of org.springframework.aop. The throws advice is used to handle exceptions. This advice is executed only when the exception is raised. The advice has to implement org.springframework.aop. The throws advice, it is just a marker interface. Exception handling code is considered cross-cutting code and can be done for entire service layer in throws advice with different kinds of exception parameters. To configure throws advice, we develop a business interface and its implemented class. We develop a class that implements throws advice interface. We then override its throwing method. Cross-cutting code is written here. We then get a proxy. We make a method call, and then the throws advice can take any of the following forms: public void after throwing, or public void after throwing, and the method, the object arguments, the target, and the exception.
If getting your learning started is half the battle, what if you could do that for free? Visit Skill-Up by Simplilearn. Click on the link in the description to know more.
Let's look at configuring AOP in Java applications using the Aspect-J approach. Now there are two ways to use Spring AOP Aspect implementation. You either create it with annotation or with XML configuration. We'll need to download the Aspect Weaver jar file to get this functional in our application. Here are the steps. For annotation with Aspect-J AOP, we have @before annotation applied before calling actual method, @after applied after calling actual method, @around applied before and after the calling method, @after returning applied after calling actual method and before returning result, after throwing applied if actual method throws exception, @point cut is used to define your point cut, and if you give in its various forms, it can be applied on all public methods or on all public methods of operation class or on all the methods of operation class, etc. And @aspect declares the class as aspect. Let's look at @before. So there are two classes here, perform and track performance classes. So here is perform and here is tracker performance. Assume that perform class contains actual business methods. The aspect J before advice is applied before the actual business logic method using @before advice. So here you see @before, point cut with the operation, and @aspect. So this is the tracker class which is going to track the performance class. So you see the output, it says calling message. Before advice called, it triggers this, then the message method, then it calls the method, then before advice again, the second method invoked, and then before advice again, method invoked. Then we have the @after annotation, which is where we use the same person class and track performance. Person class is the same, but @after annotation in the track performance class is used in this case. So the aspect and the point cut remain the same, only @before is replaced with @after. And you can see the difference. Instead of the befores now, you have the afters getting triggered, which is after the methods individually are called, and you can execute that method to take appropriate action after your business methods have executed. You see the around now getting replaced here instead of the before and after, and the code rather pretty much the same. And now if you look, you have a additional concern before, additional concern after, again for the second method a before and the after, and that is the impact of the @around annotation. XML configuration based AOP, it uses the following XML elements to define advice. AOP before, it is applied before calling the actual business logic method. After is applied after calling it. After returning is applied after calling the actual business logic method. It can be used to intercept the return value. Around is applied before and after calling the business logic method, and after throwing is applied if the actual business logic method throws an exception. So here you see the application context file. You see both the beans with IDs, the class operation and track operation. The point cuts have been defined with the expression. And here if I need a before or an after, so here you see the before, and if you need an after, this is the code that you will go ahead and specify. So let's look at advice versus aspect J. In advice, the Spring Aop is best used for application specific tasks such as security logging transactions. This is a proxy based AOP. You can use method execution point cut only. There can be little runtime overhead. It needs Spring Jar files only. Aspect J contains friendly design patterns. This supports all point cuts. There is less runtime overhead than that of Spring Aop, and you need extra build processes with Aspect J compiler, or have to set up LTW or load time weaving. We'll now start with a demo on Spring Aop, and we'll go through both the classical approach by the advice classes and the Aspect J approach. So AOP, or aspect oriented programming, as we discussed, speaks of aspects or events or advices. For example, before a method is executed, what advice is to be given, or after a method is executed if you want some type of action to be performed. Now AOP is constructed on the proxy design pattern, and the proxy pattern is actually a call which is made to an actual server via a proxy server. So the concept here is that the proxy interrupts this call, takes up the call, and as if it is the real server, and then forwards it to the actual server. This can be useful for auditing purpose, where you want to create an event log or a logger where you want to track every action that is performed in your application. And there are two approaches in AOP. The classical approach, where we have to write advices in a separate class, and it takes a lot of bean config to write in the XML file, or the modular or aspect4j option, which is via annotations, where one central class can handle aspects of any other classes. All methods that start with is, for example, is valid, etc., is where you want to perform a check when all typical methods are executed. Or if you want to track your application, this concept can be used again using aspect4j. You can also use regex expressions with modular approaches to get this done in a very simple way without having to do too much of configuration. So first we will look at the classical approach. Now I have a simple Java project here that is named as classical, as you can see. There are a couple of jar files that we have referenced. The first jar file that we will need is the commons logging jar that we had already downloaded in the previous example, and we can just Google for it and download it. Then we need all of the Spring Aop jar files, or rather the Spring jar files. So the Spring framework that we had downloaded in the previous demo, we have just added all of those files here. And we will also need AspectJ for the implementing AspectJ Aop and AspectJ Weaver. Both these files also we can just Google for them and download it. So these are the external libraries that have been added, or the external jars that have been added to the project. Then we created a new package and we called it com.to, and we created a simple business object or entity class here called SumBO. Inside it, we have written a validate method that simply prints validation stuff from BO, and we have overloaded that method with another method called validate, which takes the age parameter. If the age is less than 18, it throws an arithmetic exception that says not valid age, else it prints a simple message that says vote confirmed. We will now learn how to build aspects and advices around it. So there is another package that I have added which is called com.apps. In this package, a new class I have added called after advisor. Now this is the code that will execute after the function validate is called and any appropriate action has to be taken. So here you see after advisor, which has to implement from the interface after returning advice. We provide the implementation for the after returning method, which takes 3 arguments. And here we say some stuff post method call and argument dot get name. Okay, that is the code that exists in the after advisor. Now I have added one more class called the before advisor. Now in the before advisor, it implements an interface called method before advice and provides an implementation for a method called before. Here we just log a message saying logging before call of method argument dot get name. Then I have added a third class called both advisor. So both advisor will trigger a call, as we saw in the slides, before and after the execution of the method. So here we simply print before method. We then call the proceed, so it proceeds to the next step, and then after method. So it will execute the validate method in the business object and then it will proceed to call the after method. Finally, in case there is an exception, we have an exception advisor that implements throws advice and provides a method after throwing. Here we just print a message which says additional concern if exception occurs. Now we need the configuration file. So I have added a new XML file. This file could have any name like in the previous demo. It's called beans.xml. Okay, we have added all the references that are actually required on the top. So this is the standard header. Here is the first bean that is getting configured. So this is ID equal to BO. This is a custom name that we have given for our SumBO class. Then we have said BA, which is a ID that stands for the before advisor class. AA stands for after advisor. BH is an ID for both advisor and EA for the exception advisor. Then we have added a inbuilt class which is org.springframework.aop.framework.proxy pattern. And here we have said name equal to target, reference equal to BO. That means all these advices will be targeting this particular class object and methods. Then we have a list of values that we would want to populate according to the advisor that we want configured. Finally, we add a new package called com.exe, within which we add a class called main.java. In this class, we use the Spring framework to generate the object and inject it into our main method, which is SomeBO.class. So we get the bean and we pass a reference to that proxy ID that we had given, and we call the validate method. Then we also have a overloaded validate method that takes an int parameter. We put it in a try catch block because that throws an exception. Now, if you look at the bean config file, it is config to AA, which means the after advisor code is expected to execute. So let's go to the main and we'll execute this. And we will see validation stuff from BO, which is the validate method, and some stuff post call has been executed. So this is the after advice that has got executed, which is some auditing work or tracking work that you want to perform after the function is called. You can see that the after advice automatically executes. Now let us modify this and let us change this to 19 and save it. Once we execute this, you will see that it now calls some stuff post method called, then it actually calls the second method vote confirmed, and it again says some stuff post method call. So that is the after advisor executing after each method call. Now let's go to the beans.xml file and we change this value to BA, which stands for the before advisor. So we'll make this BA and save this. Now when we execute this, you can see it logs a call before the validate method, then it executes the validate method, then again it logs before call of method validate and vote confirmed. So this is the code that got executed twice, once before each method. Now let's go back to the beans.xml and we'll configure this as BH, which is the both advisor or the around advisor. Let's go to the main and execute this. And here you see before and after method functions are called, where you can take appropriate audit action, or if you want to log something, you can log it as well. If we change this back to 17, it will generate the exception. And you see here before method, after method, it only executed the before method, the exception was raised, so the method did not complete and hence the after method is not called. Now you can also add multiple aspects. So let's say I add another one called EA and I save. We again run. And here you see before, validation stuff, after, before, additional concern if exception occurs, and so this is the println that ran from the exception advisor class, saying that if the exception occurs, then you also have an exception which will run. We will now see the AspectJ approach, which is very similar to this approach, but with much better options, where you do not have to do too much of configuration and you can actually get everything done just by annotation. I'll open this project that I have called Aspect Approach. Let's go and look at the jars that have been added. Again, I have all the Spring Aop or the Spring Framework jars that have been added. Besides that, I have the commons, the AspectJ and Aspect Weaver jars, which have been downloaded from the web. So these are the referenced libraries which have been added. Post this, we created a new package called com.businessObject. Within it, we created a business object class very similar to the previous example. Here we have a validate method and we've overridden another, or rather overloaded another validate method that simply checks for the age and throws an exception or prints a message. We added one more class to this project, which is Central Aop Aspect. Now this is the class that is actually doing all of the validations, or rather all of the logging before, after, both, around. So all the options are now there in a single class rather than configuring everything in the beans.xml. So let's look at what's there here. We have imported the relevant packages from AspectJ. We then put the annotation @aspect because this is the aspect class. We provide the point cut annotation where we are targeting the execution of a method that starts with the word valid and is there as part of the SumBO class. So we have a method called validate. So this is going to track and map to that method. And the asterisk here indicates anything that comes after the word valid, which is, in our case, our method name is validate. And the dots indicate that it can take no arguments or any arguments. So we have two methods, one called validate, which takes no arguments, and another one which is overloaded that takes the integer argument. Here we have a function v that now stands for the validate function. So when the validate function gets called, this will execute. Then we have a before, as you see here. So this is the before annotation and this is the method that will get called before validate. Here is the after annotation. So this is the method that will get called after the validate. These method names could be anything as long as it takes a value of or passes an object or accepts an object of join point and maps to this synonym tag over here. Then the around, which prints before and after calling the actual method, and proceed, and then we return that object. And this is the after throwing for the exception. Any exception that is thrown from this class, we print additional concern, the method signature, the exception, and the end of after throwing advice. So you see the code is all now structured into a single class as against 4 different classes that we had to create with the previous approach. So hence this is much more simplified and much more easier and logical to write as compared to the previous demo. Let's go to the beans.xml and you'll see the header remains common. Here we configure the SumBO object. Here we configure the Central Aop Aspect class. So that is the class that we had created. And this is the bean org.springframework.aop.aspectj annotation aware aspect j auto proxy creator. So this is the class that we need to map to get this functionality working. Now let's go to the aspect class, and here we'll just have the before and after functional. So we'll comment this. So we just have the before, right? Or probably let me comment this as well. Let me come to the main and we'll attempt to execute this. So here you see before method validate and before method validate int, and it throws the exception then. Now let's come back to the central aspect class. We'll also uncomment the after and run this. And there you see we have the before and after for the validation, again the before and after for the int, and then it throws the exception. Now let's comment this bit. We'll uncomment this bit and we'll try the around annotation, and let's come to the main class and execute this. And now you see the additional concern before, additional concern after, additional concern before, the after did not execute because it was an exception. Let's come back here. We'll comment this and uncomment the after throwing, and now execute the main method. Now here you see the additional concern, the method signature, the exception, and the end of after throwing advice. And that is exactly what this particular annotation was managing. If we get rid of all the comments, it will execute the entire block. So we'll come to main and execute. And there you see now all of the aspects triggering that we have added. And if we correct this to 19, we will not have the exception thrown. So here you see additional concern after calling after method. So that shows us how easy it is to use AOP to actually configure our application to write before and after join points that will execute and advices that will execute before and after our functions are called, so that we can do some important initialization, cleanup, or also logging activity from an audit trail perspective. The key takeaways from this session have been that Spring MVC is used to develop web applications that uses MVC design pattern. Spring MVC is used to make web application development faster, cost-effective, and flexible. Dispatcher servlet, handler mapping, controller, model and view resolver are the components of Spring MVC. The key takeaways from this session have been that Spring Jdbc is used to build data access layer of enterprise application. It is a mechanism to connect to the database and execute SQL queries. The database related logic has to be placed in separate classes called DAO classes. Connection pooling is a mechanism of pre-creating a group of database connections and keeping them in cache memory for use and reuse. It provides high performance and efficient resource management, and Spring supports two types of transaction management, programmatic and declarative. So the key takeaways from this session has been that AOP is used in applications that have cross-cutting concerns, where a piece of logic or code that is written in multiple classes and layers as per the requirements. Spring defines two types of point cut. Static, where it verifies whether the join point has to be advised or not. It does this once the result is cached and reused. Dynamic, it verifies every time as it has to decide the join point based on the argument passed to the method call. Spring uses the dynamic proxy approach. A dynamic proxy class is a class that implements a list of interfaces specified at runtime so that a method invocation through one of the interfaces on an instance of the class will be encoded and dispatched to another object through a uniform interface.
Now with that, we have come to the end of this session on Spring MVC in-depth tutorial. If you have any queries regarding any of the topics covered in this session, or if you need the resources that we have used in this session, then please feel free to let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.